Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems and want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hello, everybody. Welcome to Wednesday night math night. I'm so excited to spend my Wednesday night with you. And that's not a joke. I really do enjoy solving math problems, helping you understand some of these problems and helping build that confidence and clear up that testing confusion. Before I get started, I always like to do a little introduction because it helps me know who's in the room and how we can kind of tailor our conversation. The problems are set in stone. However, the rabbit trail conversations we take are not. So in the comments, let me know where you're from, what test you're prepping for, and do you have any plans for July 4th? Before we meet again next, July 4th is going to come and go. So where are you from? What test are you prepping for? And do you have any family traditions or plans for July 4th? I live here in Central Florida. I am a math coach. And we don't really have any plans with the little one. I'm not sure what we'll do. We might go to a friend's house or something and watch fireworks from their back porch because they can see the big city fireworks from their back porch. But that's about it. Nothing crazy. So hence the fireworks all over my screen that I doodled while I was waiting for this to start. So welcome everybody. I'm so excited you're here. One more thing. As I am working through problems, please, please, please ask questions. That's why we're here, so that you can understand what I'm doing. So if you have any questions at all about what I'm doing, please ask it in the comments. And if there's anything that you want me to go over next week or the week after in my questions, please let me know what kind of content or topics you would like to see. It really helps me prep the week ahead, but it also helps you get what you want to see out of these Wednesday night math sessions. So, hello, welcome from Texas. Oh, grades 4 through 8, and you are next. You're next week. Awesome. Hey, Shauna from Florida, recent college grad. Congratulations. Awesome. Hey, Gary, good to see you. Your plans are studying math. Yes. When is your exam? I forget when your exam is. Hey, Joseph. Good to see you from Connecticut. We are from all over the place today, and I love it. All right, let's get started with problem number 1. And while we're doing that, I'm going to go ahead and remember to drop you the link for these problems. So as Dr. A said, I'm going to drop the link for you. It has to upload because I forgot to upload it like usual. But I'm going to drop the link for you later tonight of the questions that we're doing so that you can practice them later, or you can practice them later tonight as you're studying. You can do these problems independently. All right, so problem 1. Hey, Hope, I haven't seen you in a while. Welcome. Okay, the areas of 2 similar triangles are 196 and 81 square units. If the base of the larger triangle is 20 centimeters, what is the length of the corresponding side of the smaller triangle? We did one like this last week, but I just feel like scale factors are really confusing for a lot of people. So I wanted to make sure we did another one just like it. Got a couple people from Texas. Awesome. So when we look at 2 similar triangles, what they're saying by saying that they are similar is that their proportions are the same. So let's do a quick review of what similar means for our new people, because I see quite a few new people in here tonight. So similar means that if I take a picture, let's say this is my picture, and I'm in PowerPoint or Microsoft Word or anything like that, and you know how there's like the little circles all the way around it so that you can expand or contract that picture. If I expand the picture by pulling that dot, I'm going to end up with a really stretched out version of my image, right? And if I pull the image from this dot, same thing. I'm going to end up with a really stretched out version of my image that does not look the same. They don't look similar. However, if I stretch my image from one of the corners, what I end up having is an image that looks exactly the same. It's just larger. So proportionally, my image is the same. Is this a proportion-based problem? Yes, it is. However, we have to take into consideration the units that they've given us, John. Excellent question. So knowing that, that's what similar means, is that these triangles are similar in proportion. So they look the same, one's just smaller than the other. So let's say our triangles look like this. And then I have a bigger one. And this is my larger one, obviously, and this is my smaller one. This one has an area of 196 units squared, and this one has an area of 81 units squared. What do I know about area of a triangle? Area of a triangle equals 1/2 base times height. What would the height of these triangles be? Not like numerically, but where would it be? The height would be dropped perpendicular from the top down to that base. So this would be your base, and then the height would go perpendicular. The height is not one of these sides because those sides are diagonal. We have to think about height as like when you go to a doctor's office and the doctor measures how tall you are. You don't stand up against the wall with your feet far away. You stand straight up against that wall. And we do the same thing when we're measuring height of shapes. We take into consideration that we have to go straight up and down. We're not going to measure it at an angle. So the height of these triangles is going to be dropped from there. That has nothing to do with this problem. But remember, I'm also trying to make sure that people who don't need similarity can also get something out of this problem. Back to the similar problem. So I am not going to do this. 196 over 81 equals 20 over x. Why am I not going to do that? I'm not going to do that because these units are squared and this unit is not squared. It's a linear measurement. So this is how we would set up a proportion. However, the proportion is not accurate because these units are squared and this unit is not squared. It's a linear measurement. So because of that, this proportion is inaccurate. We have to make sure that the proportion we're using, everything is squared, or everything is linear, or everything is volume, which is cubed. So in order to do that, I have to figure out what's called my scale factor, which is the linear proportion of these triangles. So if I do 196 over 81, that gives me a scale factor. However, that gives me the scale factor of area, the squared scale factor. However, if I square root both of these, the square root of 196 is 14, and the square root of 81 is 9. Square root meaning something times something equals that value. So 196 over 81 is the same thing as 14 divided by 9 squared. John, you asked why this formula. Which formula are you talking about? Are you talking about this formula or the proportion formula that I'm using? So this right here inside is going to be my linear scale factor because it's the area scale factor square rooted, which takes the square out of the units squared. So now I can take that value, 14 over 9, and set it equal to 20 over x. Because this is my linear scale factor, and I've got my larger triangle on top. I'm going to put my larger triangle base on top, and then my smaller triangle on the bottom. And so now I can use cross multiplication to solve this. 14 times x is 14x. 20 times 9 is 180. My hand keeps totally messing this up. And then I can divide both sides by 14. Yes to what? Are you asking the formula for area or the formula? Oh, I was just giving that formula to show that that's the area formula. We don't need it for this problem, but I like to throw it in there because everybody needs to know it. And then x is going to equal 12.85. I can't remember exactly what the 85 something. 180 divided by 14. 12.857, which rounds up to 12.86. So our answer is A. All right, let's move on to problem number 2. Now, I'm going to warn you, problem number 2 is absolutely a calculus problem. It is a problem only for my middle school, high school test takers, 6 through 12, 7 through 12. But I promise there are other problems for everybody else. So just bear with me, hang on. I will try to relate it to something that you can also take away with you, but there's multiple problems tonight for everybody. So hang in there. Is this topic related to similar figures? Yes, absolutely. If you were given the perimeter of each triangle, you could use that ratio, right? Absolutely, Gary. That's a great question. So if they said, I love that question. If they said I'm going to erase all of this and quickly do that. If they said the perimeter of the two triangles is 196 and 81 units, and then the base is 20, then you could totally just do 196 over 81 equals 20 over x, because the units are all linear measurements. That's a great, great question. Thank you. All right. Find the slope of the line tangent to the point 1, 9 that lies on the graph y equals 2x squared plus 8x minus 1. All right. So let's just consider what this graph looks like. Middle school people, you need to know what this graph looks like, even though you don't need to know slope of lines tangent. So if I have a graph that looks like this, I know this is an upward facing parabola. You need to be able to look at those kinds of equations and immediately identify that. How do I know that? Because my front coefficient is positive and it's an x squared graph. So both of those things, this tells me it's a parabola, this tells me it's upward facing. So I have a parabola that looks like this. Could I find the vertex? Yes. Do I need the vertex for this particular problem? No. So I'm not going to waste my time doing that. To find vertex, this is just a side note, you do negative b divided by 2a, and that gives you the x value of your vertex. And then you can plug it back in to find the y value, where this is b and this is a. That's a side note. You don't need that information for this problem. Now, finding the slope of the line tangent to the point 1, 9. 1, 9 is going to be, and I should have drawn this graph through that because it told us that, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this graph looks something like this. It could look something else. I'm just totally sketching it. It doesn't have to look like that, but it has to go through 1, 9. And they want to know the slope of the line that's tangent to that. So we have a line that's going through, and because it's a parabola, parabolas are weird because it looks like that line is on top of the parabola, but it's actually not. It's just touching the parabola at that one point. That's what tangent means. It's just touching the point at one, or the graph at one point. And we're trying to find the slope of that line. Well, slope of a line tangent is the first derivative. So if we take the first derivative of this equation, then we can find slope of the line tangent. So the first derivative using the power rule, I drop that 2 in front, so I end up with 4x, subtract 1 from the 2, and then plus 8. If you don't know how to find basic derivatives like this, I encourage you to go watch Khan Academy to figure it out if you are taking the 7 through 12 or 6 through 12 test. If you're not taking one of those, you don't need to know how to find derivative. So this is the derivative. Now, to find the slope of the line tangent to that, all I literally do is take the x value of the point that we're looking for and plug it in, and that is your slope. So if I plug in 1 into this equation, 4 times 1 is 4, plus 8 equals 12. The slope of that line is 12. That's it. The first derivative tells you the slope of the lines tangent to those points. So if you can find first derivative, you can find slope of any line tangent. The exponent tells you that it has 2 x's. Yes, absolutely. So if I had y equals 4x cubed, that tells me that there are 3, and I'm actually going to clarify that. So excellent point. The exponent tells you that it has 2 x's. It actually has an infinite number of x's. All of these points have x values. If we want to be more clear with our explanation, which in this case we do, and let me kind of erase all of this. All right. So that value right here, the highest exponent you have in a graph tells you the potential number of x-intercepts there are. So on a graph that looks like this, all of the points on that graph have x values. However, it has 2 x-intercepts. However, a parabola doesn't have to have 2 x-intercepts. A parabola could do that, and that parabola has no x-intercepts. However, it has the potential to have 2 x-intercepts, because if I drew a horizontal line through that, it would cross 2 times. If it was x cubed, it would look something like this, but it could also look something like that. It has the potential to have 3 x-intercepts, but it could also have 1 or only 2. So excellent point. Excellent job. All right, let's move on to problem number 3A, 3B, 3C, and 3D. These problems all have to do with parabola, or all have to do with quadrilaterals and the relationship that those quadrilaterals has. So my elementary people, my Praxis core people, my GK people, these problems are specifically for you. However, my high school and middle school people, you also need to know this because you will have to find information based on this, if that makes sense. So, which of the following shapes does not have to have two pairs of parallel sides? Now, this is key language, does not have to have, because all of these shapes have the potential to have two parallel sides because of the new definition of trapezoid. And depending on the exam you're taking will determine what your definition of trapezoid is, because the definition of trapezoid is always changing. Some institutions say that a trapezoid has exactly one pair of parallel sides. Some institutions say that a trapezoid has at least one pair of parallel sides, which drastically changes the definition of a trapezoid. So you have to know how they're defining trapezoid for your exam. That said, let's talk about these. A parallelogram must have four sides, and it must have two sets of congruent parallel sides. That's it. So a parallelogram could look like this. That's not a rectangle. It doesn't have 90-degree angles, but it's definitely a parallelogram. A rhombus has all of that. A rhombus has four sides. It has two sets of congruent parallel sides. But the difference between a rhombus and a parallelogram is that it has four equal sides. So, is this a rhombus? No, because it doesn't have four equal sides. This is a rhombus. Is that a parallelogram? Yes, it's a rhombus and a parallelogram because it has four sides and it has two sets that are congruent and parallel. Those two lines are congruent and parallel. These two lines are congruent and parallel. They're all the same, but by definition, the rhombus still is a parallelogram, but a parallelogram does not have to be a rhombus. A rectangle has four sides, two sets of congruent parallel sides, but the difference between a rectangle and a parallelogram is it has to have 90-degree angles. So a rectangle might look something like this, where those angles are 90 degrees, but it has those parallel sides. A trapezoid, here's where it gets sticky. A trapezoid has four sides, but it does not have to have those two pairs of parallel sides. It has to have one pair of parallel sides. So this side is parallel to this side, or in the classic trapezoid that we always think of, this side is parallel to this side. So the answer to this question is trapezoid. I love that you're talking to the screen as if I can see you. Again, I wish I could see you. That's hilarious. All right, let's move on to problem 3B. Again, a problem discussing quadrilaterals. And I'm going to shift the view that we're looking at so you can see all the answer choices. Which of the following quadrilaterals has bisecting diagonals? Now, this problem was brought up last week. Someone asked about bisecting diagonals. So, for a shape to have bisecting diagonals, it has to be a parallelogram. For a shape to have bisecting diagonals, it has to be a parallelogram. That said, there are lots of shapes that classify under being a parallelogram. So when we look at these answer choices, what we just discussed on problem 3A, so I'm not going to spend a ton of time on this. We know a rectangle is a parallelogram, a square is a parallelogram is a parallelogram, a rhombus is a parallelogram, but a trapezoid does not have to be a parallelogram because it doesn't have the two sets of parallel sides. All four of these have two sets of congruent parallel sides, which makes them parallelograms. It's just that the rhombus, the square, and the rectangle have other distinguishing factors. And then a kite is definitely not a parallelogram either, because a kite has congruent sides that are adjacent to one another. So it's not a parallelogram because the sides that are congruent are adjacent to one another. And so it does not have bisecting diagonals either. What does bisecting diagonals even mean? Bisecting means cut in half. Diagonals being the connecting two opposite vertices. So if we look at a rectangle, they bisect each other when we cut them in half. Excellent question. I just gave an example. So, but if I look at this and I cut these diagonals, this is not the same as this. So those are not bisecting because they don't cut in half. Now, could I draw a kite that has bisecting diagonals? I could, but it doesn't have to have bisecting diagonals. Now, if I forgot which ones have it and which ones don't, I will draw pictures to see if I can visually see it. But be careful when you do that, that when you draw your rectangle, I like to draw my rectangle very dramatic. Like I will often, in this case, draw my rectangle that looks something like this, so that when I do those diagonals, I can see if they're bisecting or not, or if they create those 90 degrees or not, or whatever. So I like to be a little dramatic with my drawings just so that I make sure that it doesn't look too close to what a square might have. So in this case, it's 1, 2, 3, and 4, which is C. Yes, Gary, the kite has one diagonal that's bisected, not both. It's just that one right there. All right, 3C. Which of the following geometric figures must have perpendicular diagonals? So this is the one I was talking about where I would draw it dramatically. So if I draw a square and I draw the diagonals, those look like they're 90 degrees. But we don't ever want to do things based off of looks, especially in geometry. We want to do things based off of guaranteed information we've been provided. However, sometimes we just can't remember it. So I want to make sure that I show you how I draw things so that I can at least rule something out. Rectangle. If I draw a rectangle pretty dramatically, so I know for 100% fact it's not a square, and I draw diagonals, is there any planet where these angles are 90 degrees? Absolutely not. That is not a 90-degree angle. So by drawing it really dramatically, I can definitely see that a rectangle has to have perpendicular diagonals, which is going to be the same thing as a parallelogram. If I draw a really dramatic parallelogram that's really long or really tall, I'm going to very quickly see that those diagonals, and that was a terrible diagonal, that those diagonals do not create 90-degree angles. And a quadrilateral is like the broadest definition ever. And these are both quadrilaterals that did not have bisect or perpendicular diagonals, which leaves me with a rhombus. And I didn't even, in this case, I didn't even know that. I mean, I know it, but I didn't have to know it. I was able to draw a picture and kind of reason through it. Perpendicular diagonals, the only quadrilaterals that have to have perpendicular diagonals are a square and a rhombus, where all four sides are the same. None of the others have to have perpendicular diagonals. All right, one more like this. Which of the following geometric figures must have perpendicular edges? So in this case, we're looking at a shape that has 90-degree angles. What are the only two shapes that have to have 90-degree angles? A rectangle and a square. All the other shapes could have 90-degree angles, but they don't have to have 90-degree angles, which means they don't have to have perpendicular edges. All right, that covers our quadrilateral exploration tonight. Let's keep moving with some other problems. I'm going to go back. I'm kind of going back and forth between high school and elementary, middle school. So we're going to go back to a high school problem. This is a pretty beefy problem, but I promise there's moments of understanding for everybody in this problem. Find the center and radius of this circle. What a problem. So, because the x is squared and the y is squared, I know it's a circle or an ellipse or a hyperbola. And they told us that this is a circle. So I need to get this into circle format, which is y equals x minus h squared plus y minus k squared equals r squared, where r is your radius and hk is your center of your circle. Now, how am I going to do this? The only way I know how is to complete the square. Completing the square is also an option for you to factor a quadratic. Not my favorite way to factor a quadratic, but it's an option. But that's pretty much the only way that you can get a circle that's in this format or a like a parabola that's in standard form into vertex form. So completing the square is a long, lengthy process. So let's just jump in and talk about it. So I have 4x squared plus 4y squared plus 4x minus 12y plus 1 equals 0. The first thing I'm going to do to complete the square is move anything that's a constant to the right of my equation, because I noticed that my x values and y values are all on one side of the equation, and my r value or my constant is on the other side of the equation. So I'm going to subtract 1 from both sides and just get that 1 over there. In the same step, I'm also going to put my x's together and my y's together. I can't do anything with these x's and y's, but I'm at least going to get them near each other. Now that I've done that, I'm going to move forward with my completing the square process. Completing the square is taking a section of an equation and making it a perfect square. So the first thing I'm going to do is factor out something from these x's and something from these y's, because in order to complete the square, the value in front of the x squared and the value in front of the y squared has to be 1, no matter what. So I'm going to divide 4 out just from these two terms. So I'm left with x squared plus 4. And I'm going to do the same thing here. I'm going to divide 4 out just from those terms. And I'm left with y squared minus 3y equals negative 1. Are you with me? Now I'm going to add a blank. Whatever I do to one side, I have to do to the other. So watch. I'm going to add a blank here. And I'm going to add a blank here. And I'll explain why in a minute. But if I add a blank on one side, what do I have to do? Add a blank on the other side to keep that equation balanced. Just like I subtracted one from this side, so I subtracted one from this side. If I add something here, I have to add it here. If I add something here, I have to add it here. So by doing that, what I'm doing is I'm going to end up turning this quadratic into a perfect square so that it can look like this. So what am I going to put in that blank? Completing the square is a very formulaic process. And so I'm going to do the same thing every time. To complete the square, I'm going to do negative b. No, I'm going to do b divided by 2 squared. I was getting my vertex form and my completing the square mixed up. So what is b divided by 2? B is 4. Oh, 4x. Oops, that should be an x. So 4 divided by 2. Oh my goodness, I am so sorry. This should not even be a 4. Why should it not be a 4? Because I divided it out. So because I pulled the 4 out here, what ended up happening, yes, Joseph, thank you. I forgot the x, but I shouldn't have had the 4 because I divided it out. 4 divided by 4 is 1. So by dividing this by 4, I should have 1. So 1 divided by 2 squared is going to be 1/4. 1/2 times 1/2 is 1/4. Yes, I'm completing the square to put it in standard form, John. Good question. I'm going to do the same thing here. Negative 3 divided by 2 squared is going to be positive 9/4. All equals negative 1. Now, what I add to one side, I have to add to the other. But here's where people make the biggest mistake. This is technically not a 1/4 because it's inside of parentheses where the 4 would ultimately be multiplied by it. And so I'm going to end up adding, what is 4 times 1/4? 1. And what is 4 times 9/4? 9. So even though I'm adding 1/4 and 9/4 to the left side of my equation, technically, eventually they're going to be multiplied by that 4. And so technically I'm adding a 1 and a 9. How did I get 4? Yes, Hope, thank you for correcting me there. Now that I've done that, what I've actually done is turned this into a perfect square trinomial. But instead of sitting here and trying to figure out how to factor it, I can actually take the b divided by 2 value and just put it in there. So I end up with 4 times x plus 1/2 squared plus 4 times x minus 3/2 squared equals 9. Now, how did I figure out these values? They literally came from my b divided by 2. That's the beauty of completing the square. Once you have the formulaic process, it's really quite simple. It's long, but you know how to solve it. Now, let's go back and look at the standard form. What do you notice? There's no value in front of the x and the y. So we have to divide that 4 out. So I'm going to divide everything by 4. It crosses off here, so I'm left with x plus 1/2 squared plus y minus 3/2 squared equals 9 divided by 4. What does that tell me? That tells me that this is my center and this is r squared, which means I have to square root it to find my r. So the square root of 9/4 is going to be 3/2, which tells me C and D are automatically out. And my center is going to be at -1/2, 3/2, because we take the sign that's opposite to find the center. Why is it -1 + 9 plus 1 plus 9? Because what I did is I added the same thing to both sides. However, because this is inside parentheses, I have to multiply it by what's on the outside of those parentheses. All right, that was a long, very meaty problem. I have another problem that is completing the square. What I'm going to do, I'm not going to do this problem tonight. I'm going to copy the link for tonight's slides. I'm posting it right now. What I want you to do, if you are a middle school or a high school person, I want you to try to solve this problem using that formulaic process we just used to put this into standard form, or to put this into vertex form, because this is standard form and these are vertex forms. So I want you to do that this week, come back next week, and see how to do it. I'm going to solve this problem next week. So take the Dropbox link and solve this problem this week on your own, and then we'll kind of check it since I already did a completing square problem this week. All right, classic geometry problem. I love these kinds of problems. A 2.5-inch wide frame is to be designed around a piece of art that is 5 feet by 7 feet. If the wood costs $2.25 per square inch, how much will the frame cost? So this is a very common problem-solving problem that you'll see. You'll also see a pool in a deck, a frame, some paint on a wall, all very similar problems. We have to visualize this problem before we can do anything. So we have a piece of art that we know is 5 feet by 7 feet. And then they've also told us that there's a frame around it that is 2.5 inches wide all the way around. And they asked us, if the wood costs this much, how much will the frame cost in total? If the wood costs $2.25 per square inch, how much will the frame cost? So what I have to do is find the area of that frame. There's 2 ways I can do that. I can find all of these little rectangles, areas, add them together, and then multiply by $2.25. Or I can find the area of this really big rectangle that we've created and then subtract out the painting, which is going to give me the leftovers, which is that wood. So that's the way I'm going to choose to solve it. You can solve it whatever way you want. So let's go ahead and erase some of these extras. I know that my frame is 5 feet by 7 feet, and that my picture is 5 feet by 7 feet, and my frame is 2.5 inches around. Problem number 1, I've got feet and inches. So I'm going to convert my feet into inches because the cost is per square inch, which is the ultimate measurement or unit that we're going to use. So I know 1 foot equals 12 inches. To get from 1 to 12, I multiplied by 12. So I know that 5 feet is going to equal 60 inches because 5 times 12 is 60. And I know that 7 feet is going to equal 84 inches because 7 times 12 is 84. So I'm going to replace the 5 with a 60 and the 7 with an 84. Now, what else do we know? We know that this frame is 2.5 inches all the way around. So step number 1 is find the area of the big rectangle. Then I'm going to subtract the painting out from that. And then I'm going to find the cost. So the area of that big rectangle, what are the dimensions of that big rectangle? How big is this rectangle on this side? We know it's not 60. What is the dimension of that rectangle? Number one common mistake is for people to say that it's 62.5 because they do 60 plus 2.5. However, we have to think that there's 2.5 down here too. So it's actually 60 plus 2.5 plus 2.5, which is 65, which means I'm going to do the same thing on the bottom. 84 plus 2.5 here plus 2.5 here is going to be 89. So to find the area of the big rectangle, I'm going to do 65 times 89 inches. And that's going to give me, I'm going to pull out my handy dandy calculator for that. 100, no, that does not make sense. I got 154 and I said to myself, self, you probably typed something wrong. That gives me 5,785. Now I'm going to find just the area of my painting because what I just found was the area of this entire rectangle. But I need to subtract out the green. I need to subtract out that middle painting portion. And so by doing that, what's going to end up happening is I'm going to be left with only the frame. So let's go ahead and take a look at what that looks like. 60 times 84 equals, handy dandy calculator, 5,040. And if I subtract those two, like I said, we end up with what's left, 745. Now, what does that value? Oh, here I am explaining everything, and I'm not even, here you go. You can't even see what I'm doing. So 60 times 84 is 5,040, and then subtract. So now I have 745. What does that value represent? That value is what's left of my diagram, which is just this piece. Because I took the whole rectangle and then subtracted out that middle piece. So that is the inches for the frame only. Now, what do I do with that? I take that and I multiply it by $2.25 to find the cost. 745 times $2.25 equals 1,676.25, which is C. How do you make a diagram for this? And explain how. I just explained how I do the diagram, so I'm not really sure what you're asking because I thought I pretty clearly explained how I got this diagram. That pink in the middle is my picture frame, or my picture, and then the outside is the frame. And why did I subtract? Because I did the area of the whole thing, the picture and the frame, and then I took out that painting from the middle. All right, we have time for one more problem, and then we're going to talk about what you guys want to see next week. Which of the following best describes the faces of the following figure? You guys are saying you can't see. Can you still not see? I'm not sure if the comments are just maybe a little bit delayed. I reconnected it, so let me know if you can see it now. Which of the following best describes the faces of the following figure? So this is a prism. We have to understand what a prism is to its core to be able to solve this. So what is the definition of a prism? A prism has two identical bases with rectangles surrounding the shape to close off that shape. How many rectangles do we have? The number of rectangles we have is equal to the number of sides on my base. The number of rectangles is equal to the number of sides on one base. And that would make sense because if I have a base, then what's going to end up happening is I need a rectangle for each of the sides of that base. So in this case, we have a triangle as a base, and then there's going to be another triangle back here. And then there's rectangles around the shape enclosing this shape. So this is technically called a triangular prism. This is technically called a triangular prism. The page is too far up. I'm not sure what you mean. Because on my screen it looks totally fine. So I don't know what you mean. If you can like maybe screenshot it and send it to me on Facebook. That way I can like kind of fix it for next week, but I'm not sure what you're talking about where it says the page is too far up because on my screen it looks fine. But please send that to me on Facebook if you have Facebook so I can maybe fix it for next week. So this is a triangular prism. I know I have two triangles, and then how many rectangles am I going to have that go around it? I'm going to have three rectangles. One rectangle for this side, one rectangle for this side, and one rectangle for this side. Now, that said, what kind of triangles do I have? Do I have equilateral triangles or do I have isosceles triangles? I know these are isosceles triangles. Equilateral triangles have three equal sides. So if this was an equilateral triangle, they would have done something like this. If it was an equilateral triangle, they could have also said that this was a 60-degree angle and this was a 60-degree angle, which means that this would have had to have been a 60-degree angle because in a triangle, we know that there's 180 degrees, and 180 minus 60 is 60. So in this case, I know it's not equilateral. So it has to be isosceles, and we can assume that it's isosceles with three rectangles because we've not been given the dimensions of these rectangles. So we can't assume that there is a square involved. So the only thing we can assume is that there are three rectangles. All right, we have one leftover problem that we'll finish next week. I want to talk about what we're going to also do next week. Someone has specifically requested a problem using binomial expansion, not using Pascal's triangle. So we will definitely do that next week for my high school people. Everybody else, if there's anything else that you want me to add to this list for next week, please comment in the comment section so that I can add it to this list next week. I love making sure that I add things that you guys need. So please let me know what you want to see next week. Can I work a problem where you have to decide whether a non-right triangle is acute or obtuse given some combination of sides? Absolutely. Acute, obtuse, based on sides. Yep. You can rewatch this video on Facebook or on YouTube. It will be, I think we just leave them on YouTube. So you can absolutely find all of our replays on YouTube. Can I add permutations, combinations, probability? Absolutely. I probably won't be able to go over all of those next week, but throughout the month, I will make sure I hit permutations, combinations, and probability. Maybe I'll do one a week or something like that. All right, I'm going to turn it over to Dr. A. I will still be here monitoring the comments if you have anything else you want to see next week. Have an amazing July 4th, and I will see you all next week. Continue to let me know what you want to see me working through next week, or if you come across a problem you're working through this week, send it to me on Facebook or in our customer group, and I'll be happy to add it. With that said, I'm going to turn it back over to Dr. A. Thanks, y'all.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.